Assalamualaikum warahmatullahi wabarakatuh.
Waalaikumsalam warahmatullahi wabarakatuh.
Today we are from group 12 are gonna present our material today. But first we are going to introduce by member. First, my name is Thariq Munandar.
And I am SUSI RHOHMAWATI.
I am DEWI IRMAWATI.
Okay. And next material will present by
Okay, I will be present our materi computer, the internet, and new media for learning. Context and intercultural history. The legacy of the Enlightenment neglects the age-old debate between empirics and idealists in the early 20th century. The debate centered science could be used not only to observe the external world with microscope and telescope, but also to change condition and control behavior. The most notched behavior in the educational domain, Bruce Frederick B.F. Skinner contribute the idea of operant conditioning, how positive and negative reinforcement, reward and punishment can be used as stimuli to shape how humans respond. With this variation, the theory of behavior modification was born. All human actions are seen to be shaped or caused by the stimulus of the external world on the body. In short, there is no mind creating reality, merely a hardwired system that responds to what is experienced from external source. With the advent of the computer and man-machine studies in the post-war period, interpreted behavioral scientists designed and used drill and practice methods to improve memorization. Thus, AG surpassed 1966 they turned to an examination of the role and efficacy of computer and technology in education, a subject understood in behaviorist research agent that values measurable result and formal experimental methods. As Cosman. Intercultural technology beginnings of computer aided instruction and examination of the theoretical roots of computer in education exposed its behaviorist beginnings. The computer could reinforce activities that could bring about more efficient learning. For some, this means chapter. For others, faster, and for yet others, it means without needing a teacher. See Bromley 1998 for a discussion. The oldest such tradition of computing in education is CIA. This approach dates back to the early 1960s, notably in two research projects at Stanford under Patrick Soppos, and the programmed logic for automated teaching operations or Plato project at the University of Illinois at Urbana-Champaign, or UIUC under Donald Bates and Dad Albert. Both projects will be used the then new time sharing computer system to create learning opportunities for individual students. From this beginning, CIA and the model is Providence for educational technology are now the oldest tradition in educational computer, although only partly integrated in the school system. CIA is widely used in corporate training and recruitment and in remedial programs and has had something of resurgence with the advance of the World Wide Web, whereas online training has become popular. Cognitive science and research on artificial intelligence. In order to situate the historical development of learning technology, it is also important to appraise the impact of what Howard Gardner, 1985, refers to as the cognitive revolution on both education and technology. For our purpose, the contribution of cognitive science is twofold. First, the advance of the digital computer in the 1940s led quickly to research on artificial intelligence or IA. Second, cognitive science, specifically the contribution of Piagetian development, psychology, and IA research gave the world the first practical models of mind, thinking, and learning. Cognitive science, especially by way of IA research, opened the box for the first time. Research could work from a model of mind and mental process. The most significant thread of early research was Alan Newell and Herbert Simon's information processing models at Carnegie Mellon University. This research sought to develop a generalized problem-solving mechanism based on the idea that problems in the world could be represented as internet states in a machine and operated on algorithmically. From internal representation to situated action. In short, the question of how does IA and cognitive science development have affected the role of technology in the educational arena can be summed up in the ongoing debate between instructionist tutoring system and constructivism toolkits. First, the earliest application of IA to instructional system attempt to operate by creating a model of knowledge or a problem domain and managing a student's progress in terms of deviation from the models. Surface 1966, Wenger 1987. 87. Later or globally more sophisticated construction systems look more like toolkits for exploring and reflecting on one's thinking in particular role. The role of technology in learning. When theorizing about the role of technology in learning, the tendency is often to use an instrumentalist and instructionist approach the computer. For example, is a useful tool for gathering or presentation information. or which is often and incorrectly acquainted with knowledge. The next session is organized less technological and more functional and examines technology from a variety of perspectives as information source, curricular areas, communication media, tools, enforcement partners, scaffolds, and perspectivity toolkits. In the latter, we return to the importance of using the points of viewing theory as a framework from designing new media technological devices. Technology as information source. When we investigate how meaning is made, we can no longer assume the actual social meaning, material may consists only in the verbal semantic and linguistic contextualization, or paradigmatic, systematic, intertextual, by which we have previously defined them. We must now consider that meaning, managing, use, organized, orients, and process directly or implicitly through the resource of multiple semiotic systems. More recently, the rise of the Internet and the World Wide Web has stimulated the production of computer-based curriculum resource once again as a sort of universal multimedia platform, and web's ability to reach a huge audience very inexpensively has led to its widespread adoption in school, training center, corporation, and significantly the home. Technology as curriculum area. Driven by economic urgencies, chronic labor shortage in IT professions, Maris and Sarget, 1999, the extensive impact of computer and network in the workplace, and the promise of commercial success in the new economy. Learning about computer is a curriculum area in itself, and it has a major impact on how computer and technology are viewed in educational settings. A most a most straightforward conclusion that one might draw from looking at our economy, workplace, and prospect for the future is that computer-based technologies are increasingly part of how we work. Technology as communication media. The notion of computer as communication medium or media began to take hold as early as the 1970s, a time when computing technology gradually became associated with telecommunication. One called Possedes immersive virtual environments as perfectivity technologies as the correct space for participants to create and share their work. The Internet has clearly opened up enormous possibilities for shared learning. The emergence of board standards for Internet software has lent a stability and relative simplicity to learning software. Technology as thinking tool. Although it is easy to think of the computer as simple tool, a technological device that we use to accomplish a certain task as we use a pen, abacus, canvas, ledger, book, file cabinet, and so a tool can be much more than just a better pencil. It can be a vehicle for interacting with our intelligence, a thinking tool, and a creative tool. This idea that children could be designer of their learning environment was developed further by Yasmin Kafai, who introduced computer design as environment to understand how girls and boys think when playing and designing games. A topic of great interest to video game designers, Kafai 1996 in short Caffeine connected the world of playing and designing to the life of the classroom in a number of studies. Continue to expand paper legacy with a new generation of graduate students. Okay, next will be present by Susi Rohmawati.
Alright, I will continue the next material. The next material about technology as partner. Technology as partner to conceive of the computer as a partner in cognition of learning. Our work is to admit it into the cultural milieu, to foreground the idea that the machine in some way has agency or at least influence in our thinking. If we ascribe agency to the machine, we are going some way toward anthropomorphizing it. The notion of computers as cognitive partners is further exemplified in research conducted by anthropologists Lucy Suchman at Xerox PARC. Suchman's plans and situate actions. The problem of human-machine communication explore the difference between rational purpose plans and circumstantial negotiate situate actions. And then technology as scaffold. This version makes reference to Vygotsky's construct of the ZPD, defined as the distance between the actual developmental level as determined by independent problem solving and the level of potential development as determined through problem solving under adult guidance or in collaboration with more capable peers. This scaffold metaphor originally referred to the role of the teacher, embodying the characteristic of providing support, providing a supportive tool, extending the learner's range, allowing the learner to accomplish tasks not otherwise possible, and being selectively to usable. For example of technological scaffolding comes from George Landau's research into using hypertext and hypermedia nonlinear reader-driven text and media. And next, technology as perspectivity toolkit. Perspectivity technologies provide a platform for sharing, not always share, values and for building, not only participating in, cultures or communities or practice. Because we live in a complex global society, this new model is critical if we are to communicate with each other. Goldman Sachs digital ethnographies of children thinking are exemplars in perspectivity theory. A good example of perspectivity technology is described in the doctoral work of Maggie Pierce, who working with Goldman Sachs in the Maryland Research Lab, explore how per-service teachers learning modern language, build and critique digital artifacts connecting self and other. And then about exemplary learning system. The following is a college of technological system designed to aid, enhance, or inspire learning. The first is Logo. Logo is a dialect of the AI-rich language LISP and was developed by Wally Verzig's team at both Beranek and Newman or BBN, working with paper. Paper's work made computer programming accessible to children, not through dumping down computer science by carefully managing the relationship between abstract and concrete. The Lego movement was very popular in schools in the 1980s, and many versions of the language were developed for different computer systems. Some implementations of Lego depart from Paper's geometry microwords and were designed to address other goals such as the teaching of computer programming. And then Square, it is a multimedia personal computing environment based on the Smalltalk, by the object-oriented programming language that form the basis of Kai's investigations into personal computing. Square is notable in that it is freely distributed on the internet, runs on almost every conceivable computing platform, and is entirely decomposable out of and can create new media tools and presentation as with other environments. And then Boxer. Boxer is a computational medium, a combination of a programming language, a micro-world environment, and a set of libraries and tools for building tools for exploring problem solving with computers. Developed by Andrea Di Sessa, a Boxer plans to logo work of say more paper and the mutable medium notion of Alan Kay in a flexible computing toolkit. Boxer thought to extend the local research into a more robust and flexible environment in which to explore basic concepts. And then their HyperCard, as as there was very little multimedia software available in the late 1980s, Apple decided to bundle a multimedia authoring toolkit with every Macintosh computer. This toolkit was HyperCard, and it proved to be enormously popular with a wide variety of users, and especially in schools. HyperCard emulates a sort of magical stack of index cards, and its multimedia documents were thus called stacks, and other called add text, image, audio, and even video components to cards, and then use a simple and elegant scripting language to tie these cards together or perform certain behaviors. To board categories of use emerged in HyperCard. The first was collecting and enjoying pre-designed stacks. The second was altering one's own. And then Constellation or Orion. Constellations is a collaborative video annotation tool that works with the metaphor of stars and constellations. Stars can be combined to make constellations, but different users may place the same star in different contexts depending on their understanding by viewing data from various perspectives. And then Adventures of Jasper Woodbury. Jasper Woodbury is the name of a character in a series of adventure stories that CDGV used as the basis for uncoded instruction. The stories present on video discs or CD-ROM are carefully crafted mysteries that present problems to be solved by groups of learners. Since the video can be randomly accessed, learners are encouraged to explore parts of the story in order to gather clues and develop theories about the problem to be solved. The Jasper series first appeared in the 1980s, and there are no 12 stories. And then Cat Pix was the first kid-friendly generic graphics studio program. It includes a wealth of design tools and features that make it easy and fun to create image, and it has been widely adopted in school. KitPix was originally developed by Craig Hickman in the late 1980s for his own son and was subsequently marketed by Border Point Software, or now owned by the learning company. And then CSILE, Merlin, Scott Damalia, and Carp Beriter at OISE developed CSILE as CSILE is a collaborative problem-based knowledge building environment. Learners can collaborate on data collection, analysis of findings, construction, and presenting conclusion by exchanging structured notes and attaching further question, contribution, and so on to pro-existing notes. And then Starlogo. Starlogo is a parallel computing version of Logo by manipulating multiple uh, of distribute turtles. Learners can work with interactive models of complex interaction, population dynamic, and other decentralized systems. And then most coursing. Most coursing is thus a microworld that learners can themselves enter, design, and programming the virtual environment from within. It becomes a sort of life in text that one shares with other readers, writers, and designers. That's all. The next material will be presented by.
Okay, thank you. The next is SimCalc. SimCalc is a project at the University of Massachusetts working with Jeremy Rochelle and Ricardo Nemirovsky. Core software allows learners to manipulate variables and see results via real-time visualization. SimCalc's tagline is democratizing access to the mathematics of change. Next is participatory simulation. Participatory simulation is a distributed computing environment built on the foundation of Logo and NetLogo that encourage learners to explore complex simulation. This project centers around HopeNet, a classroom-based network of handheld device that enables learners to participate in and collaboratively control simulation of the dynamic system. Next is COFIS. COFIS was a project developed at Northwestern University in the 1990s. COFIS made use a variety of network software, Much of learners' investigation center on atmospheric and environmental studies. Learners could then use data analysis tools to visualize and draw conclusions. Next, next is network science. Large-scale research project explored the possibility of connecting classroom for data sharing and collaborative inquiry. Programs like National Geographic Kids Network reach thousands of classrooms and tens of thousands of students. Other projects such as Classroom Birdwatch and Energy Net focus on issues with global and local significance. Next is Virtual U. Virtual U is a web-based course delivery platform. Harasim Calvert and Groeneboer in 1996. Virtual U aims to provide a rich, full future campus environment for learners. It features a cafe and library as well as course material and course management functionality. Next is Tap In. The Tap In project led by Mark Schlarger at SRI International began in the late 90s as a MOO or textual virtual reality environment for synchronous collaboration. It now functions more like an ongoing teaching conference with many weekly or monthly events and workshops. Next is CoWeb. The computer can be a tool composing and experiencing dynamic media. Georgia Tech CoWeb project explores possibilities in designing and using collaborative media tools online. Squeak is a direct descendant of Alan Kay's research at Sherlock Park in the 1970. Next is Mamama Media. Mamama Media is a collection of dynamic websites aimed at challenging young children to explore, express, and exchange ideas. The company was founded by MIT Media Lab graduate. Mamama Media enables girls and boys to be online playing games and learning how to think like the DEWI. Next is WebGuide. WebGuide, a best collaborative knowledge constructions tool, was created by Jerry Stahl and colleagues at the University of Colorado. WebGuide is designed to facilitate personal and collaborative understanding through mediating perspectively via cultural artifacts. Effective computing and wearables. A series of researchers projects at the MIT Media Lab are aimed at investigating effective computing. Effective computing involves the emotional and environmental aspect of digital technologies. Jocelyn Schreier explored how effective wearable technologies become expressive devices for augmenting communication. And next is WebCity. WebCity was developed by Murray Goldberg at the University of British Columbia in the 1990. Today, WebCity is used more than 1,500 institutions for online course. WebCity now a company is almost the facto for standard for online course delivery. And next is challenging paradigms and learning theories. First is from the cognitive revolution to cultural psychology. The cognitive revolution of the late 1950 and early 1960 1960 was a lost opportunity. Argues philosopher Jerome Bruner had imagined that the search for meaning would be at the fore. Distinguishing it from behaviorism, the information processing model of cognition becomes so dominant. Brunner argued that the role of meaning and meaning making ended up as much in disfavor as they had been before. Brunner has been part of movement calling for a return to the role culture in understanding the mind. Next is cognitive effect, transfer and culture technology, a brief narrative. In his 1996 article, Timothy Kosman identified four defining paradigms of technology in education. These are drill and practice and program instruction system, ITS, which drew on AI research to create automated system that could evaluate a learner progress and a tailored instruction accordingly. The logo is Latin paradigms and TSGL, which focus on learner in practice in group. The literature surrounding learning technology display example of incommensurability, even within the writings of individual theories. Next is bricolage and meaning making at MIT. In the early 1990s, scholars and MIT Media Lab were exploring how knowledge and meaning are constituted in community, culture, and technology. Theorizing on epistemological pluralism, Turkle and Papert clearly revealed the tension between the cognitivist and situative perspective. P.A. offered a critique of Papert's construction theory from standpoint of distributed intelligence. Not until the late 1990 did the research at the Media Lab move toward distributed environment and the cultures and practices within them. Next is learning thinking attitudes and distribute cognition. Stage theory has tried to show how maturation takes place in logical causal sequence or states according to observable states in growth patterns. Developmental theories such as Freud, oral, anal, and genital states, Erickson's 8 states of psychological growth, Piaget states from sensory motor to formal operational thinking, are based on the belief that the human organism must pass through these states at critical periods in its development. Think about thinking as essentially evolving states of development requires the kind of calibration possible only in world of statics, rules, and universal truths. Carol Gilligan argues that in the different voice of woman lies an ethic of care, a tie between relationship and responsibility, and the origin of aggressions in the failure of connections. Evelyn Fox Keller argues that science is deeply personal as well as a social activity historically preferential to male objectivist manner of thinking. Next is epistemological pluralism. The emphasis on pluralism is in constructionist practice was also a major theme to emerge from the MIT Media Lab in the 1980s. Sherry Turkle book The Second Self explored the different style of mastery that she observed in boy and girl in logo classroom. Papert and Turkle led MIT's Media Lab epistemology and learning group to a revaluation of concrete. Next is multiple perspective and thinking attitudes. Goldman Segal's framing is rooted in Marvin Minsky. Article intelligence and Howard Gardner theory of multiple intelligence sees learners as ethnographers observing and engaging with the cultural environment they participate in. The focus had clearly changed from understanding the mind of a child to understanding the situated minds of collaborative teams. Simultaneously, the learning moved from learning modules to open-ended constructionism to problem-based learning or PBL environment. Next is distributed cognition and situated learning. In cognitive apprenticeships, model knowledge and learning are seen as situated in practice. Situation might be said to co-produce knowledge through activity. This idea is carried forward to an examination of tools and the way in which they are learned and used. Jean Leff and Etienne Wenger brings the situate perspective firmly home to the learning environment. In Leff and Wenger, they argue that the nature of communities of practice is that knowledge is spread over a community and is embodied in the mature culture of that community, both in the mechanism of practice and in the shared history of community. They also argue that artifacts and technology are not just instrumental in embodying practice. They also help constitute the structure of the community. Well, that's it. That is the result of our group discussion. Thank you for watching. Wassalamualaikum warahmatullahi wabarakatuh.